Hello friends, welcome back to the bench. Today we have a curious case of Surface Pro 4. This one is actually 512 model with i7 CPU, so very much worth a repair, and I'm not the first one to attempt it. I love receiving goods from other repair shops and just kind of seeing if I can do something better, right? if I can succeed where someone else failed. It's very rarely, but it happens. With this one, it's actually very curious. So this is what it does. We flip it, we connect it, and it charges with full current. 1.4, 21 watts right now. So almost full. 23 would have been like maximum. Right, and we switch it on. It goes to 30 watts, which is correct. Stays on for a second and dies. And then it goes back to charging again. So, I know what you're thinking. Short. Something is shorted. But if it was that easy, it wouldn't have made it to me. Because short would have been easy to find. So, where I started, actually I started with visual inspection. So the majority of shields were bent and like really put on not properly. Like really, someone really struggled taking them off. And I can say I blame them because yeah, these are tough to take off without any damage to them. But when it starts, so first thing I check is vCore, right? I turn it on, we have vCore. Memory, we had memory for that second, yeah, 1.2. We have memory. Which means we're gonna have 3.3 and we're gonna have 5 volt standby. We're gonna have 1 volt over here and we're gonna have 1 volt over here, and we're not gonna have 1 volt over here, but if we turn it on we have 1 volt. So all voltages are correct. If there was a short, one of those would be not present. Since it turns on, we know that EC is powered, but let's check that. We should have roughly 300 millivolts on EC. And let me switch you over to the scope, because this is a lot smaller. This resistor over here, that's our EC power. There, 272 millivolts, perfectly fine for EC. Besides, we know it works because we have let's check VSys, but if there wasn't VSys, we wouldn't have 5 volt standby. The vCore or VSys, we can check over here on this resistor. We have 8 volts. So VSys is fine because, well, if VSys was missing, the battery wouldn't be charging, and this battery charges perfectly fine. So I can't see any shorts, so I decided to look at it under the thermal camera. Perhaps something is gonna be visible there, but nothing is. So the only thing warming up are 1, 2, 3 MOSFETs, normal, that's vCore. I don't remember what this one is called. The memory chips are lighting up, turning on, perfectly normal. And that's it. No visible blips or anything like that. So, since I couldn't find anything, I decided to look into what has been performed to it so far. As you can see, I already took this off, because not only this was ripped off, which is very common. It's actually, I've opened many of these at this point, and while I no longer crack the screens or disable the digitizer or break the digitizer, all my screens come off cleanly. I still get, sometimes I rip one of the antennas. And the reason is, well, it's not glued on the other side, and it is glued, the adhesive is over here, it's glued to the screen. It's very hard to take it off without any damage to the antenna. But this one has been ripped off here and broken over here. But what's interesting is that someone decided to fix it with a solder. So this was patched with solder. Will this work? To a certain extent it will, but there's a lot more to antenna than just continuity. You know what I mean? It's not like you do something like this and the antenna now works perfectly fine. The SWR probably has changed. Remember that antennas resonate on certain frequencies. So geometry for antennas is extremely important. So no, don't do that. Don't do that. Just replace it. It's not expensive, especially for this machine, i7. This is i7 CPU, so our V-core resistance is like 4 ohms. You can see that, could you? On V-core, we have 4 ohms, right? So, and on VCC GT, even lower than that, we have 2.5, roughly 2 ohms. So this is very powerful CPU that we have over here. And I believe 8 gigs of RAM, but I don't know. Well, it's at least 8 gigs of RAM. So, having all that information, what can be wrong? Normally, it's the short. EC turns on and it waits for PG signals from everywhere, and it waits a few seconds. And if one of the PG signals is not present, it shuts down. It basically resets. So that fits our behavior over here. It fits our profile. But there are no shorts. So the next thing is look into the BIOS. So once EC turns everything on, and we know the CPU turns on, the memory turns on, once all that is done, then we ask our BIOS chip for the code that will initially run. And then after the BIOS is loaded, then we can access SSD and start loading the system. So the BIOS is the first thing that's going to load, and for that we require a CPU. So if the CPU is something wrong with the CPU, this would behave like this. But if the BIOS is corrupted or there's something wrong with the BIOS chip, this will also behave like this. It will just turn off. Although usually when it turns off, it's usually the electrical problem. Usually when the BIOS is corrupted, it usually just doesn't turn on at all. But I'm saying usually, you know, I've only had a handful of cases where the BIOS was at fault. So the next step is to see whether the BIOS is loading the program, right? The binary. For that, we want to check the CSpin, which is this one. That is chip select, and that will be high when the chip is not used, and it will go low when the chip is used. And over here, we should see basically a signal. It's going to be jumping from 3.3 to 0 and back to 3.3 again. And first, let's grab this one. This is the working computer. So I can show you what it's supposed to look like. So we are going to clip on to here. to catch the ground. Then touch the chip select and turn it on. See that? So that is what we expect to see on the working machine, right? And now let's turn it off. How do we turn it off? Let's monitor vCore. Oh, it did turn on. It did turn off for some reason. Well, that's fine. I'm not sure why it turned off. Maybe I made a short with the oscilloscope, who knows. So let's jump to our machine that doesn't work, and let's do the same test. Find the CSpin right here and turn on. It went up and it never went down. Oh, it went down for a second. But not what we expect. So we could check the data pin. Which one is the data pin? There's two data pins because this is SPI. So there's gonna be MOSI and MISO. SPI clock is here. SO SI. So SO SI, so input output, they're also called MOSI, MISO, or yeah, there's few names that are given to these pins. Now let's see which one is going to be easiest. Let's try this one, SO. So that's an output pin, I assume. It's right next to the right next to CS. So it's this one. Yeah, the data is coming through. But it was like a really quick burst of data, and again. So we had two very quick bursts of data. So this could be a BIOS issue, but let's take a closer look at the BIOS chip. I'm not sure how well you can see that under this microscope, but we have a flux residue. The chip is slightly misaligned, so that tells me that this chip has been removed from this board and something has been done to it. If it was reflashed, well, if it was corrupted and was reflashed, well, if it's corrupted, then reflash is pretty much your only option. But if you do the reflash, the touch will no longer work. So we can do a few things. One thing would be to desolder it and read the chip, see if we can read the binary, and then perhaps maybe upload this binary to a different computer and see if the different computer will work. Pretty lengthy procedure. So I propose this. Let's desolder this chip and solder on another chip. That will cause the computer not to have a working touch, which is fine, but will tell us that whether the previous chip was okay, whether it's a BIOS issue at all. Yeah, there's the flags floating, burnt flags actually. Oh, what's wrong with this? There's some crappy flags that was left on it, and the chip is sticking to the board. That was crazy. What is this flags? Now let's fix the damage. This is not supposed to be this hard. I don't know what it was, but the chip that just wouldn't stick, it wouldn't become loose. And did you see how much heat I had to use? This was definitely removed, and it's a little starved of solder in my opinion. I would put a little bit more solder on this. Yeah, this looks like NC flags, the crappy MTech NC flags. Well, there are no ripped pads or anything like that, and area around it is good and clean too, so you know, it's not like this was botched job. It was fine. So let's keep this one here, and let's get one of these guys. There should be enough solder. Let's put some real flags on it. RMA. Now it feels like there's enough solder, because there's also a little bit of solder on the chip. And now we'll see if the behavior is exactly the same. We know it's not the BIOS issue, which means it's going to be a CPU issue, with which there's nothing we can do. Now let's let it cool down for a second, maybe clean some flags, but that's not completely necessary, at least for the test. It is completely necessary when you're done, right? And it's customer ready, so yeah, that's when you clean the flags. But for the test, it's fine. Cool down quickly. Alrighty, and now the moment of truth. Is it gonna behave differently? So, if now it stays on, that means there's something wrong with the BIOS, either corruption or maybe the chip itself is faulty. In either case, we're not going to be able to fix this one. I mean, we can fix it to, so it boots to Windows, but the digitizer won't work, so it's kind of pointless. So this will be parts. If there is no difference, it's a CPU, and also there's nothing we can do with that, which is too bad, because this is i7. Okay, I'm not sure if you can see anything on the screen, but let's boot it. It didn't go back to 0, and yeah, it's on. Let's check the vCore. If we have vCore now, and we do, yeah. So this could have been a BIOS issue. Let's turn it off and connect the screen and see if we're gonna have anything on the display, because it wouldn't display anything before. Come on, there. Okay. Let's see. It will take a little longer to boot. I'm not connecting digitizer because with this BIOS chip it's not gonna work anyways, so don't bother. Still nothing on the display. And the power draw is too low. So something was related to the BIOS. Yeah, it would have displayed something on the screen if it was actually booting. Let's see if we have the same reading on the oscilloscope as we did with the previous chip. That will eliminate the BIOS being a culprit here altogether. If we see the same thing on the scope, that is definitely a CPU issue. I don't see anything on the BIOS. So CS is not pulling low, and there's like some weird jitter on CS. On output, same kind of jitter, but it's low on this one. Yeah, it's got some weird jittering. Alright, so that's not a BIOS. Not a BIOS means there's nothing we can do with this one, because that means it's the CPU that is not reading the BIOS. And it does get warm. It's not shorted, it just doesn't work the way it's supposed to work. Could it be cracked solder? It could be. But I would guess it's rather overheating. The Surface Pro 4s that usually make it to me broken, right? The ones that I actually have to fix are always 256 or 512. That means they have more memory, better CPU. 128, on the other hand, very rarely I get 128 that there's anything wrong with it other than broken battery, I mean used up battery, or just plainly cracked screen, or digitizer not working or something like that. These are pretty much the only faults that I get on 28s, because 28 is not overclocked as these are. These seem to be overclocked, and they suffer like almost every other one that I get. There's something wrong with the CPU. I mean, I've had one that had EC chip shorted, and I think I have this board here somewhere. Yes, so this one had shorted EC chip that we removed, and where is it? Over here. Right, and I never replaced it, so now I have a donor to replace it. But I think this one was 128 as well. I can't remember, but judging by the CPU, I say that's 128. So the i7s have 3 sections, 3 chips on this big chip. 128s have 2. And I think 512 also have, not 5, the 256, the 512s have definitely, the i7s had 3 sections, but I think the 256 also have 2 sections. So this is not exactly worth a repair, replacing the AC chip, but especially since I no longer have a BIOS for this one. I desoldered the BIOS and it's one of these. I don't know which one, and so either way, if we fix this one, the touch is not gonna work. Unless I find the exact chip that I took out of this one, but probability is very low. So either way, this is scrap. And since this one has a CPU issue, this is also scrap. Well, no fix. So again, the other repair shop was right to sell this one as broken, because it was not an easy fix. Well, as they say, you can't win them all, right? Alrighty, I think that'll do. We will scrap this one, take the battery out, maybe after recharging it. Let's keep it recharged. We have a perfect battery, and unfortunately, yeah, the other thing, the heatsink is bent over here, so the heatsink is also to be trashed, and that is very common. Like every other one that I get, this is bent, because it's like natural reaction to just after you unscrew these two to just kind of lift this up. I've done that before, and yeah, the heatsink will never work the same after you do that. And this one's still on. I can feel it heating up. So it's still on. It doesn't boot. So yeah, I guess the CPU right now is not communicating with BIOS. So I'm gonna blame CPU, because it gets all the voltages it needs. Yeah. Alrighty, thank you very much, fellas, and I shall see you in the next one.